So all our previous work in terms of instantaneous rates of change were about instantaneous rates of change in time. So now we're going to talk about instantaneous rate of change in space. This is basically just the idea of slope. So for example, for the function y equals x squared, or really the graph of y equals x squared, what is, we can say, the average slope to start, just like we start with average velocity, we start with average slope from x equals 1 to x equals 2. Okay, so let me show you graphically what we're talking about here. So here's our nice y equals x squared. Let's get a nice color for that. Blue for y equals x squared. So there's y equals x squared. And then we're going to look at the points x equals 1 and x equals 2. And what we're going to do is we're going to say, if I look at this point and this point, well, okay, that's supposed to be nice and straight, like that, okay? And then I draw the line that goes through them, the line. Then what would be the slope of that line? All right, so a couple of words. So first of all, this line is intersecting the curve at 2 points. If I really sort of zoom in on that, you know, what does that really look like? Like the curve really is like doing this, and the line that I'm drawing is going through like that. So it's touching the curve at 2 distinct points. Okay, so a curve that does that, line that touches the curve in 2 distinct points is called the secant line. Okay, so definition, I guess. Yeah. The secant to a graph is a line touching the graph at 2 points. So there's something a little bit naive about that. So it's really touching it locally at 2 points, because this graph could like go up and curve back down over here somewhere, and the graph could touch it at the line could touch it at a third point. But we're really interested in sort of a local area of where we're sort of concerned with the graph. So it's really touching the graph locally at 2 points. We could say 2 or more points, but there's some complications no matter how you define it. So anyway, that's called the secant. All right, and by the way, it comes from geometry, where if you have a circle, all right, and then the case is much less ambiguous, because line can only touch a circle at either 2 or 1 point. So this is called a secant to that circle. So a secant line touches the circle in 2 points, and a segment included in the circle is called a chord, right? So it's called a secant. We use that idea of secant to a circle, and we apply that to graphs and say, okay, so we have a line that touches the graph in 2 points, and that's called a secant. So it's important that the secant touches the graph at 2 points, because since it has 2 points, we can find the slope in the most direct way, which is the slope, which is equal to y2 minus y1 over x2 minus x1. So if I think of these as being a and b, then the associated y values are f of a and f of b. So I could also write this equation, the slope equation, y2 minus y1 over x2 minus x1, as f of b minus f of a over b minus a, and then you recognize it as being the same thing as the average rate of change, because it is. Okay, so now for this particular function, we can say that the slope of the secant is equal to 2 squared minus 1 squared, right? That's f of 2 minus f of 1 over 2 minus 1, and that equals 3. So that's what the slope of the secant line is. Okay, so of course what calculus wants to do is say, what if instead of 2 points, I want to know the slope at 1 point? So what if I want the slope of the graph at just 1 point? Just like when we were talking about instantaneous rate of change, we said, what if I want to know the rate of change, but not over an interval, at just one exact point? So that's what the calculus would be for, and that is what we're going to call the slope of the tangent line. Slope of tangent. Right? So if I look at the graph that I've drawn here, so the graph of y equals x squared, now, let's see, what's the first point I'm going to do? I'm going to do x equals 1? Yeah, sure. Okay, so here's my graph. Let's say I just want the slope at x equals 1 and nowhere else. So I want to look at just the point here, and I want the line that touches the graph at exactly 1 point and not 2 points. Okay, so that is called the slope of the tangent. And again, it's by analogy to a circle, where if I have a circle and a line that touches the circle at exactly 1 point, that's called the tangent to the circle, or a tangent line to the circle. You might remember all that from geometry. Okay, so our real calculus goal, or this part up here is just algebra 2 at best. Okay, the real calculus goal is to say, I want the slope, but not at 2 points, at 1 point. Now, fortunately, we have a lot of preamble about how to do instantaneous rates of change, and it's exactly the same. All right, so that's what we're going to look at next.